All right. Okay, let's now get on to question 16. Question 16 says, how many 4-digit numbers divisible by 12 can be formed using the letters 1, 2, 3, 4, 5? So you want a 4-digit number divisible by 12, and you must use these 5 numbers. Let's see if you can create some. Okay, to be divisible by 12, it must be divisible by 3, and at the same time, it must be divisible by 4. It must be divisible by 3 and 4. Now, the divisible criteria for 3 is the sum of the digits must be 3. So you got 4 digits. So if you take, for instance, 1, 2, 4, 5, this adds up to 12. So this is divisible by 3. But if you want to be divisible by 4 as well, now this is not divisible by 4. You want the last 2 digits to be divisible by 4. So you can put 2, 4 at the end, put 1, 5 like that, and that is divisible by 3 and by 4. So therefore is divisible by 12. So that is one of the possibilities. Right. But they ask you to find how many there are altogether. So you need to find the whole lot. Right. So the way to do this is, you see, there must be 4-digit numbers. So if you had the whole lot, you get 15, right? And you want to remove 1 to create a 4-digit. So what must we remove? So that the other 4 digits, the remaining 4 digits, create multiples of 3 or sum. Sorry. So the remaining 4 digits sum to a multiple of 3. Now, obviously, you have to take 3 out. If you take any one of them out, any of the others, you don't get a multiple of 3. So you have to remove 3. That's the only one you have to remove. So the digits that we are looking at, so you have to use 1, 2, 4, and 5, right? And already this is a multiple of 3 to create a multiple of 4. All right, so how do you get a multiple of 4? The ending, you could have the ending of 12, 12, 14, 15 doesn't work. The other one is 24. And those two. And you can also have 52. 52 is a multiple of 4. But you'll notice that there's no other endings. These are the only pairs, only 2-digit numbers, which create multiples of 4. Right? 2 with anything else apart from 4 doesn't work. 4 doesn't have a partner. 4, 1, 4, 2, 4, 5, none of them. But 5, yes. 5, 1, 5, 2 is true, but not 5, 4. Now, here I can put 1, 2, I can put 4, 5, or 5, 4. Here I can put 2, 4, I can put 1, 5, or 5, 1, 2, 4. And here I can put 5, 2, I can put 1, 4, 4, 1. Right. Now these are the only ones. Right. The way we argued, there's no more. You have to have 1, 2, 4, 5, and you have to end in one of these three, and in each of those three, there are exactly two other numbers, which two first digits, which will give you a multiple of 4. You're not allowed to repeat. They say you use only once in each number. Right. So you're not allowed to repeat, and that gives you 6. And you can see right at the end, there are 6 such numbers. So we are on the right track. Okay, let's look at question 17. Question 17 says, Henco forgot to fill his water bottle with a long hike undertaken by him, Connor, and Sibu. Fortunately, Connor had 4 liters. Connor, but now you say this. So Connor had 4 liters. C. And Sibu had 6 liters. Or S for Sibu, we make this 6. Okay. So these guys had carried enough water. So the 3 hikers shared the water so that each got an equal amount. Okay, now take 4 plus 6, they got 10 altogether. And if you share it, then so each will get 10 over 3, which is 3 and 1/3 each. So they give this to Henco. Henco had nothing in the beginning, right? So they give him 3 and 1/3 liters. And they keep 3 and 1/3 to themselves. So now those 10 liters go on like this. Now Henco gave this guy here, he's the one who faulted. He gives 50 rands to Connor and Sibu to split between them for the water they gave him. So if the money is divided fairly between Connor and Sibu, how much did Connor get? All right, so he gave $50, and so you need to know Connor gave H and S gave H. If you want to be fair, you have to see how much did each give. Now he had 4 liters, Connor, and he reduced to 3 and 1/3, so he gave him 2/3 of a liter. While Sibu, he had 6, so he eventually had 3 and 1/3, so he gave him 2 and 2/3 liters, right? From his 6. So that's how the 2 and 2/3 plus 2 and 2/3 made up 3 1/3. But now you'll notice that this is 2 2/3, 8/3, is actually equal to 4 times 2/3. So Sibu gave Henco 4 times more than what Connor gave. So in other words, if you want a fair distribution, if Connor gets X, if C gets X rands, then Sibu, that's your S, gets 4X rands. Because Sibu gave 4 times, Sibu gave Henco 4 times more than what Connor gave. So to divide it equally, you will have to have that X plus 4X is 50. So X is 10, which means that Connor gets. They asked how much did Connor get? So Connor gets X rands. So in other words, it's 10 rands. Because we just calculated X to be 10. Sorry, we got this writing all over the place here. All right, I didn't organize myself well. So the answer is Connor gets 10 rands. Logically, you actually have to find out how much did each give. Right? Then only it will be a fair distribution. So you can see this is the answer that I got. Let's get on to question 18. Harry's hamburger hangout offers hamburgers the following choices of toppings. Now, basically, there are a whole lot of these toppings. A customer can choose 1, 2, or 3 patties, hamburger patties. So you got a choice of 3 for hamburgers. Three patties. And what about the toppings? You got tomato sauce, mustard 2, mayonnaise 3, 4, 5, 6, 7, 8. Choice of 3 patties and 8 toppings. All right. Now you can choose any collection of toppings. Now there are 8 of them altogether. And you can choose any collection from the 8 toppings. You could take all 8, you could take none, you could take 5. Right. So how many choices does he have? Okay, let's just fix one patty. We take one particular patty and say fix a patty. Right. Now that patty can have, on top of it, it can have none or 1 or 2 choices or 3 or 4 and so on, right? So how many different types of hamburgers can you create? That's what they wanted to know. How many different types of Numbers can be ordered. How many different types exist? All right. Now, here's a fact. So you can choose none, or you can choose one, or you can choose two. So essentially, you got a set of 8. A, B, C, D, E, F, G, H. These are 8 things, and you can choose, for instance, you can choose none. That's one choice. Or you can choose only one each. So you'll have A, or B, or C. So there are 8 choices there. Or you can choose 2 only. So now you got the many choices. You have to choose 2 from 8. Now, earlier on, I told you that if you choose 2 from 8, the formula is 1 times 2 and 8 times 7. And into n minus 1 over 2. 4, so this is 28. Now you can see it's really becoming quite astronomical. You have to ask how many. If you take 3, again, you can use that same formula that we got, and you can get an answer. But let me use that formula. Okay, I didn't give myself space. All right. I'm forced to create space here. And I'm going to use that. Oh, I think it's going to be quite a long calculation. But let's do it. We'll take in each case. We'll say none. No toppings. One topping. 2 toppings. 3 toppings. 4, 5, 6, 7, 8. All right. So I want to count for each one of them how many there are. If there's no toppings, that's a choice. With 1, your formula is n. You only got 1 here, right? So n is 8. You got a set of having 8 elements, and you want to choose 1. And we saw there are 8. You can put A, or you can put B, and so on. Now for the next one, it's 8 times 7, or 1 times 2. And we saw this 28. For the next one, it's 1 times 2 times 3, 8 times 7 times 6. 2 times 3 is 6, 8 times 7 is 56. The next one is 1 times 2 times 3 times 4. Yeah, 8 times 7 times 6 times 5. I'm using the formula that I did earlier with R, right? You go all the way up to 4, and here you got 4 factors. 4's cancel. And I'm not multiplying all these things out, because you can just use nice fractions here. 2's cancel, 3 goes to 6. 2 times. So you have 2 times 2 times 5, which is 20. No, 2 times 7. Oh, I don't understand my own writing. Sorry. I thought my 7 was a 2. Okay, 8 times 7 times 6 times 5. Yeah, 1 times 2 times 3 times 4. And 4 goes into this 2 times, 2 cancels with this, 3 goes into this 2 times. So you have 7 times 2 times 5. 2 times 5 is 10. So you get 70 here. And then the next one you'll have 1 times 2 times 3 times 4 times 5. You have 8, 7, 6, 5, 4. Now, actually, the number of ways of choosing 5 is the same as the number of ways of choosing 3. Because as before, we said you have to take out 3 to get 5. So it's like counting how many times you have to take out 3. And we saw that for 3, it was 56. Right? For 6, you have to take out 2, so that becomes 28. For 7, say like for instance 7 now. With A, B, C, D, E, F, G, H. Right. Now you got the one topping has got like that. But that means this has been left out. So each time you want to take 7, you have to take out 1. You have to remove 1. And that's how you get 8. And if you want to put all together, there's only one way of doing it. Okay. Now, when you try to add all these numbers, you find something quite interesting. I purposely went through this rather tedious exercise because I wanted to illustrate something to you. When you add 9 plus 28, 37, 37 plus 56 is 93, plus 70 is 163, plus 56 is 219, 247, 255, 256. So there are 256 altogether. Note, this is 2 to the power of 8. Right? This always works. If there are 8 choices, actually you're asking how many subsets are there altogether. You have a subset having no element or one element and so on. And it's always the number of subsets is 2 to the power of 8. Now here's a fact. Let a set have n elements. Look, I mean, 3 errors in one line. You know, this happens, unfortunately, as we grow older. Concentration. You notice I keep rubbing everything out because I try to punish myself. Take that out too. Let a set have n elements. Then it has 2 to the power of n subsets. Now, you don't have enough material to prove it. I can't explain that to you too easily. but that is always the case. There is an easy way of explaining it, but I'm just too concerned that I'm getting too lost up. One of the ways of explaining it is like this. Let's take this. Okay, suppose you have a set having 8 elements. I made this box too small, but it doesn't matter. So there are 8 slots to fill. In how many ways can you fill these 8 slots? Right? You can decide I'm not going to fill anything. That's your empty set. And if those elements are defined as, so if I have any one particular subset, say C, D, H, that's an example of a subset. That means I've got this filled, I've got that filled, and I got that filled. So I can put ticks in those lots. So either a block has got a tick or it doesn't. That means that elements belong to the subset. Like this one here does not belong, that does not belong, and so on. So every box here has got either a tick, which we'll put down as yes. Suppose we put yes and no, right? Or it doesn't have a tick. So that means each box can be filled in only 2 ways, either yes or no. See? So that is a quick way of proving what I said now. So this can be filled in 2 ways. This can be filled in 2 ways. 2, 2, 2, 2. So altogether, you got 2 to the power of 8 ways of filling this thing. And you can think about that. It's a little bit deep. Okay, so let's get on to the next problem, which is 19. Oh, but before that, there it is. I've got a detailed. Hey, wait a minute. I haven't solved the problem because I said for one patty, there are 256 possibilities, but there are 3 patties. For each of those patties, you got 256 possibilities. So therefore, altogether, you have 3 times. So that's how you got 768 types of hamburgers altogether. All right. Now let's get on to the next problem. Okay, question 19. An equilateral triangle is placed on top of a square of area 64. So you got a square and you got a triangle, and then you have a circle which contains these 3 points, right? I might have mentioned that given any 3 points, you can always draw a circle that contains those 3 points, exactly one circle. Okay, so suppose you draw that circle. The question is find the square of the radius of the circle. Well, it's given that the area of the square is 64. So you got a square which has got 8 by 8, and on top of that you draw an equilateral triangle. All the sides are 8. Right? And then you draw a circle, and the question is find the square of the radius. Or you can just find the radius and then square it. Okay. Now this thing has got a very beautiful solution, and I'm going to show you the solution. You might want to make a big calculation for this and say, okay, let's find out, see where is the center. And then having got the center, then you have to find the radius, right? And it'll take a while to find out where the center for this circle is, right? But there's a very elegant way of solving this problem. And it is this. If you draw a circle, oh, it's not coming right. Let me, I think I have to put it a little bit lower. So there, then you draw the square. And then you draw an equilateral triangle. Okay. Now what you do is, to find the center, drop the equilateral triangle down onto the base. I'll redraw this triangle, same triangle. It need not be very accurate, but it's the same triangle. All I do is just redraw it, which means that all these sides are equal. It's the same equilateral triangle, and this side of the equilateral triangle is shared with the side of the square. So this line is that. So you got all these sides are equal. Right? And we've said we just drop this thing down. So comes down like that. Okay. In other words, the sides of an equilateral triangle, they are parallel to themselves. I'm just dropping it down. I'm not changing direction. I'm not turning it around. So these lines are parallel. But they're also equal. Right? You see, they're both equal to this. So you got a parallelogram, because you got one pair of opposite sides parallel and equal. And that's an important result in a parallelogram context. And if you got a quadrilateral, which has got the property that one pair of opposite sides are parallel and equal, so the parallelogram that I'm looking at is this one here. Those are parallel because we didn't change direction, equal. But now, to adjacent sides of this parallelogram are equal. Look here. This is equal to this. Now, when you got a parallelogram whose adjacent sides are equal, then it's a rhombus. That shaded part is a rhombus. Any parallelogram with a pair of adjacent sides equal is actually a rhombus. So that means all the sides are equal. In particular, this red line which I've drawn, that must also be equal to this. See? And now you can see clearly this point, its distance from here, its distance from here, its distance from here is the same. So this point is the center of the circle. Call the point C. C is the center. And because you got from here, you got that point, and that point. All these are equal. We just proved they're equal. So that must be the center. Right? It's equidistant from these 3 points. Okay. And therefore, this single line is a radius. So this now becomes a radius. So the side of the square is a radius. Or the equilateral triangle. Radius is the side of the square. Or the equilateral, all these sides are equal. But I'm particularly concerned with the side of the square because they're asking for the square of the radius. So the square of the radius is equal to this, so it must be equal to the area of the square. Because this is equal to the side. And the area of the square is given, 64. So the answer to the question was staring at you in the face. The square has got area 64, and that's also equal to the square of the radius of the circle. Okay, so it's a very intriguing problem. The fact that you're dropping down and doing this is an ingenious solution. You wouldn't think of doing that. Normally you would try to calculate it. So you'll try to calculate this. We'll say, suppose this is a circle, and then put R, and make all kinds of calculations, and eventually get to what R is. See, knowing that this is an equilateral triangle, and this center must be lying on this vertical line through that. The center is somewhere here. It's not the center of the square. So it'll have to be a little bit higher. And you don't know what it is, so you have to make all kinds of calculations. This distance is the same as that distance, and same as that distance, and get an equation and solve. But that is a very long process. The one that I just gave you. Okay, I've redone this here, and you can see what the actual solution is. Question 20. What is the 50th decimal digit of 1/7? I'm surprised that they gave this question, because this is the kind of question that is asked in round 1 of juniors. So you have 1/7. Now, how do you calculate what the decimal is? What you have to do is you put 7, 1,0000. You have to divide 1 by 7. 7 goes into 10 one time. Okay, I'm not going to do it in detail, but this is what you get. It's a recurring decimal, and it's 142857, which recurs, and you want to know what the 50th decimal digit of this is. These 6 numbers, they keep recurring. So it's nice to look at the 6th and the 12th. The 7 is the 6th, the 12th, 18th. So all the multiples of 6. And you're going up to 50, so you can say 48. So the 48th digit is 7. The 49th digit will be the one after 7 is 1. And the 50th digit, the one after 7 is 4. So the answer is 4. Okay, so that's not an extremely difficult problem. So as you can see, the next solution is a very short solution. Okay, now we go on to the next problem. Question 21. Question 21 says, find the volume of a cube whose diagonal. You got this funny number here. I told you earlier on, if you've got funny numbers, you just give them some names. Call it A. Okay, so this is a cube. So a cube has got all the sides equal. So let X be a side. You don't know what this is. So you need to find the volume. So we need to work out X cubed. Because the volume of a cube having side X is X cubed. Okay, now can I get an equation involving X? We are given the diagonal. Now this is an interesting one. You see, this is kind of a 3-dimensional box. If you join, this point P is vertically above the bottom of this box. And if I join where it meets, I join it to Q, then this is vertical. And then what happens is that this line here is actually 90 degrees. The line from P is perpendicular. It's perpendicular to everything on the floor. It's like if you take a broomstick and make it stand vertically on the floor, this is the floor. No matter which line you draw on the floor to the broomstick, if the broomstick is vertical, that line makes 90 degrees. See? Broomstick makes 90 degrees with every line. So this is your broomstick, and it makes a 90 degrees with that line. This line here being a diagonal of the base. All right. So that is very nice, because we said whose diagonal is A. So that diagonal is A. Okay, now A happens to be the hypotenuse of a right angle triangle. So A squared is equal to, this is A, X, and this is Y here, right? So A squared is equal to X squared plus Y squared. So this is Pythagoras applied to this triangle here. This angle is 90 degrees. Now Y squared, now that's A. On the floor, you got that this is X and this is X. So on the floor, this is 90 degrees here. It's a box, you see. So that angle on the floor like that, that's 90 degrees. And this Y is the hypotenuse of this floor triangle, which is a right angle triangle. So Y squared is X squared plus X squared. X squared plus X squared. So that gives you 3X squared. Now, I got A squared on the left-hand side. Now, let me square this thing. If I square 3, root 3, I get 3. And if I square cube root of 17, that is 17 to the power of 1/3. Right? So I'm going to square that one. And if you use the third law of indices, that becomes 17 to the power of 2/3. A to the m, all raised to the n, is a to the mn. So here I've got 17 to the 2/3. I've squared everything here. So now the 3's cancel, and you got that X squared is equal to 17 to the power of 2/3. Right? But I wanted an X cubed. So how do I get X cubed? To get X cubed, I have to raise this to the power of 3/2. Then 2 times 3/2 is 3. So therefore I must raise this to the power of 3/2, because they are both equal. And now, lo and behold, 2/3 times 3/2 is just 1. And on the left-hand side, I've got X cubed. And that is what you're looking for. So the volume is 17. Okay, that just involves a little bit of calculation, but it's an interesting calculation which gives you a nice answer at the end.